I'm going to be referring to this document. Sorry, it flopped. But we're going to fast forward to example 10, which is in the completing the square quadratic formula section. It looks like this on the paper. The example is already on the board. Now, this one is because this is the part where it becomes a little bit more complicated because there are fractions. So we get rid of the fractions by using the least common denominator. The least common denominator between 2 and 3 is 6. So we will clear the fractions by multiplying everything by that 6, including anything which isn't a fraction. Everything gets multiplied by 6. We cancel away the denominators. So 6 divided by 3 is 2. 6 divided by 2 is 3. So we have 2 times 7 is 14 times the x squared plus 6x equals 3 times 5 is 15. I recommend putting any quadratic equation in descending order, equaling 0. So we have 14x squared plus 6x minus 15 equals 0. Okay, now 14 does not evenly divide all three terms. So it's not easily factorable, and it's not conducive to completing the square because the 14 doesn't divide all three terms. So we're going to use the quadratic formula, and this will be A will be 14, B is 6, C is negative 15. So I have the quadratic formula listed over here. So x will equal negative b is 6 plus or minus square root of 6 squared minus 4 times the 14 times the negative 15 all over 2 times the 14. Okay. The first thing we do is we calculate under the radical. So that will be 6 squared minus the 4 times 14 times the negative 15. That's 36. There's actually 2 minuses involved with this, so you'll be adding. That's 840. Altogether, this is 876. Second, we simplify the square root of 876. We look for a perfect square which divides 876. Since it's even, we'll try 4. So 876 divided by 4 gives me 219. 219 isn't divisible by any such number, so we're done. We'll have the square root of 4 first, and the square root of 219. The square root of 4 is 2. So the last thing we do, having taken care of the radical, we now have x equals, we deal with the larger expression, negative 6 plus or minus 2 times the square root of 219 divided by 28. All three terms are divisible by 2. All terms are divisible by 2. Negative 6, 2 times the radical, and 28 are all divisible by 2, so we will do it. Negative 6 divided by 2 is negative 3. 2 square roots of 219 is just a single square root of 219. And 28 divided by 2 is 14. That's example 10. Example 11. Is x over x minus 7 minus 11 over x plus 7 equals 98 over x squared minus 49. Keep erasing. I'm going to clean this up to be neater. Okay, so here's example 11. The first thing you're going to want to do is factor any denominator that is factorable. Now, you also want to find the LCD to clear the fractions. This is the LCD, least common denominator. Reason being, it includes the other two denominators as factors. This includes both other denominators. This equation will also have excluded values. X plus 7 cannot equal 0, and x minus 7 cannot equal 0. Neither one of these can equal 0, nor can this. Okay? So x cannot equal negative 7. X cannot equal 7. We have to avoid any value which would make a denominator equal 0. Okay, because division by 0 doesn't exist. So x cannot equal these two numbers. Now, we're also going to clear the fractions. So we will multiply everything times the LCD. I would use factored form for this. You should too. So that's what it looks like. Multiplied by the LCD, multiplied by the LCD, multiplied by the LCD. Now cancel away your denominators. There should be no more denominators when you're done. And over here, both cancel. So you just have x times x plus 7 minus 11 times the x minus 7 equals 98. This is going to be x squared plus 7x. X squared plus 7x minus 11x plus 77 equals 98. Forgot the x here. Now these two combine to form x squared minus 4x plus 77 equals 0. I'm sorry, equals 98. So I'm going to copy this over here where there's less clutter, and I'll show you what's going to happen. So this is just all that recopied. And then we need one side to equal 0, so I will subtract the 98 over here. And I get x squared minus 4x minus 21 equals 0. Okay. Now, just because we know the quadratic formula can play in the square doesn't mean we should always necessarily use it. Always check to be sure that this is not factorable. Okay? I look for two factors of negative 21. So this is an x squared. I look for two factors of negative 21 to have to negative 4, and they exist. Negative 7, positive 3. So x minus 7 equals 0, and x plus 3 equals 0. Okay? Add your 7. X equals 7 over here. Subtractor 3, x equals negative 3 over here. Here's the problem. This is excluded. But this is fine. So x equals negative 3 is your only solution. I'm going to pause here and resume this video in a moment. Okay, so that was example 11. Let me get this off the board. And we will move on to example 14. I didn't want to erase the quadratic formula, so I'll put it back up. Okay, so example 14. You guys are capable of reading examples 13 on your own. Here's example 14. Negative 2x squared minus 22x plus 120 equals 0. It's already in descending order, but the lead coefficient is negative, so take it out. And then all three terms are also divisible by 2. So the lead coefficient is negative, take that negative out. They're all divisible by 2, take that 2 out as well. And be careful to divide. So negative 22 divided by negative 2 is positive 11. And 120 divided by negative 2 is negative 60. Okay? Next step. We divide it off. Okay. So these cancel. 1 times this leaves this. And 0 divided by negative 2 is still 0. Now, before we start trying to get fancy with completing the square of the quadratic formula, let's check to see if it's factorable. So the lead coefficient is 1. Okay, I look for two factors of negative 60 to have to negative 11. They are 15 and negative 4. So, x plus 15 equals 0. X minus 4 equals 0. Subtract your 15. And x equals negative 15. Add your 4. And x equals 4. So in order from least to greatest, x equals negative 15 and 4. Okay? All right. Example 15. Three x squared minus 6x minus 153 equals 0. Okay?
Sorry, am I in the right classroom?
I'm going to switch classrooms. The room I'm using is going to have an early start to a class. Okay, I have moved to a different classroom. As I explained before, I had to pause. Another class is going to be using the room that I was in. They're starting earlier. Normally they don't start until 2. Today they're starting at 1:30. So to have a review session. So naturally I moved. And because I could not see what's on my video camera, I'm having to move things around. Okay, I'm not starting the video all over again because I'm already too far along for that to be too. Let's see. I was going to do. I was showing, I believe, examples 10, 11, 14. And I'm on 15 and 17 is next, I believe. Okay? So here goes. Let me see if I can get this a little closer. I think I'll move the chair over. All right, so starting all over with this example. 3 divides all 3 terms. So we take it out, like so. Okay? And then we'll divide that factor off. And we end up with x squared minus 2x minus 51 equals 0. Now, if we do completing the square, because this is conducive to that, the coefficient is 1, that's even. Okay, so if I was to complete the square, that would be one method I could use. Here's the other method is to use the quadratic formula. I'll start with the quadratic formula. My quadratic formula. So A is 1, B is negative 2, and C is negative 51. Okay? So, x equals negative 2 plus or minus square root of negative 2 squared minus 4 times 1 times negative 51 over 2 times 1. Okay? Now, the first thing you do what's under the radical. So you have negative 2 squared minus 4 times 1 times negative 51. Okay? I'm trying to avoid tripping over a cord that's right behind my legs. So this is 4. There's actually 2 minuses here, so you'll be adding. And I believe that will be 204, which gives me 208. Next step, square root of 208. (208) is divisible by, let's see, left the calculator in the other room, so I have to whip out another one. 208 is divisible by 4. So I tried 4, but the result I get is 52, which is also even. Okay? So 52, I'll see if it's divisible by 4 as well. I got 13. Okay, so 52 is high, and 52 is divisible by something other than 4. I'm sorry, 208 is divisible by something other than 4. So I'll try 208 again and divide it by 4. I get 52. 208 divided by 9 gives me a decimal. Okay? So now I will try 208 divided by the 16. I get 13. Okay? So 208 is divisible by 16, and the division result was 13. Square root of 16 is 4. So the last thing I have is x equals positive 2 plus or minus 4 square root of 13 over 2. 2 divides both of these. 2 divided by 2 is 1. 4 divided by 2 is 2. We're going to keep the square root of 13. If I do this by completing the square, I got x squared minus 2x minus 51 equals 0. Add your 51, and we will have x squared minus 2x equals 51. Okay. You always follow your steps. At the top of this sheet is a set of steps for completing a square. Right here. Just like with the quadratic formula. Follow those steps exactly. So you will you're going to be cutting something in half and squaring it. You'll be taking the negative 2, cutting it in half and squaring the result. That's negative 1. Negative 1 squared is 1. Add to both sides. Okay? So we have x squared minus 2x plus 1 equals 51 plus 1. Okay? This is factorable. This is 52. So 2 factors of 1, that to negative 2 are negative 1, negative 1. So this gives me x minus 1 squared is 52. Now, x minus 1 equals plus or minus the square root of 52. 52 is even, so I'll try to divide it by 4. I got 13. Okay, so x minus 1 equals plus or minus 4 plus or minus square root of 4, and that gives me x minus 1 equals square root of 4 is 2, so plus or minus 2 square root of 13. Square root of 4 is 2. Last thing I need to do, isolate the x. So I will add 1, and x equals 1 plus or minus 2 square root of 13. When you write this in standard order. Okay? Both methods work. This is not, because you got a rational solution, you couldn't have used factoring past this point. Okay? I'm going to pause. All right, I have example 7 here on the board, or 17 here on the board. To me, this is not easily factored. 7 does not divide all 3 terms evenly, so I'm going to use the quadratic, and it's not x, the elite coefficient is not x squared, so the completing the square wouldn't work well for it. So I'm going to use the quadratic formula. A is 7, B is negative 9, C is negative 10. So x equals negative 9, plus or minus, the formula's over there. Negative 9 squared minus 4 times 7 times negative 10. All over 2 times the 7. Okay? So first, you want to calculate what's under the radical. So we got negative 9 squared minus 4 times 7 times negative 10. So that's 81. There's actually 2 minuses here, so you'll be adding. It's 280, which is 361. Second, you calculate, you simplify the radical, and the square root of 361 is actually 19. Okay? All right. So the last thing you do is you have 9 plus or minus 19, no radical. It's just plain and simple 19 over 14. Okay? Because there is no radical, there is no imaginary unit, these numbers can actually be added and subtracted. So you have the potential for 9 minus 19 over 14, or 9 plus 19 over 14. Well, 9 minus 19 is negative 10 over 14, which reduces to negative 5 sevenths. This is 28 over 14, which evenly divides as 2. So x actually equals negative 5 sevenths and 2. All right. And that is all 5 of them. And this is where I stop a very chaotic video.